Hi, this is Stanley and Jocelyn's project. We are having some audio issues, so I will be doing a voiceover for us instead. Our project is on US murder rates. For our final project, we decided to do a statistical analysis of rates of murder in the US. We chose this topic out of interest in the different rates of crime between states. We are also impressed by the quality of data that was available to us on the rates of all different types of crime, which was then organized by state. This gave us confidence that the results we could obtain would actually tell us something about our country. Our data was drawn from the year 2013, and we drew two hypotheses. First, that the mean number of murders per 100,000 people for each state would be less than 5. Second, that the proportion of states that had less than one murder per 100,000 people would be less than 25%. This is what our data looked like. You can see on the left is the list of states, next is the population, and then each column corresponds to a category of crime. You can see on the top, the numbers are in per 100,000, and this is from the year 2013, and we picked this data set because it is the most recent one available. Since we drew from an already collected dataset, we did not personally apply any data gathering techniques. The dataset that we studied was collected in the year 2013, and it found the rates of many different types of crime in the US and categorized them by state. We did focus on the specific crime of murder out of all the types of crime. We imagine that this dataset was created using crime info collected by the US government. Since crimes and imprisonment are all recorded in the US, this dataset could just draw from those numbers. Additionally, this would not be considered a sample, since they are able to draw from the entire population. This would be more of a census than a sample. The data is representative of the population because it was collected from the entire population. We believe that the data was collected by a census rather than a sample. A census is a complete enumeration survey, which means that each member of the population is studied. In our case, this means that each crime committed in the year 2013 is looked at, rather than taking some samples of crime from each state and extrapolating the percentages that way. A census is more accurate than a sample because it is literally the measurement that the sample tries to represent. We do not have to worry about that with a census. Of course, the drawback is that a census takes much longer to conduct and takes more resources. Alternative ways. We believe the data must be representative of the population, since our dataset collected data from the entire population. Thus, it is not representative of the population, rather it is the population. However, this method requires the most time and effort. If we did not have the dataset already and had to collect the data on our own, we would use simple random samples of prisoners and simple random samples of prisons in each state and survey them on what crime they committed. That way, we could track a much smaller number of crimes. We could find the random sample of prisoners using a random number generator, and we could also pick the prisons in this way. This method could have some potential biases, though, such as the prisons that we selected not being representative of the rest of the state. For example, prisons in certain locations might have higher rates of specific types of crime. This would be Jocelyn's part. The data collected allowed us to test whether our hypotheses were accurate. For the mean hypotheses, we proposed that the population mean number of murders in the US in 2013 was less than 5 per 100,000 people. The analysis of the confidence intervals indicated a slight deviation, suggesting that the actual mean was very close to 5, supporting the null hypothesis H0. Regarding the proportion hypothesis, we suggested that at least 25% of states would have fewer than one murder per 100,000 people. Our confidence intervals and hypotheses testing revealed that fewer states than anticipated met this criterion, aligning with the null hypothesis. Overall, our interpretations of the confidence intervals were consistent with the conclusions of the hypotheses tests. While the data did not strongly support our alternative hypotheses, they provided valuable insights into crime rates in 2013. Further research could investigate murder rates over a more extended period to identify trends and patterns. By including data from multiple years, we might determine if the 2013 rates were an anomaly or part of a larger trend. Analyzing demographic or socioeconomic factors could also provide insights into why certain states have lower murder rates. Additionally, exploring the effectiveness of crime prevention policies might help explain variations across different regions. Another avenue for research could be comparing US murder rates with those of other countries to identify global patterns. These potential studies would deepen our understanding of crime rates and help develop more effective policies. Our project focused on analyzing murder rates in the US in 2013 by testing two hypotheses. The first hypothesis proposed that the mean number of murders per 100,000 people was less than 5. The second hypothesis suggested that at least 25% of states had fewer than one murder per 100,000 people. We used official crime data and applied hypothesis testing methods, including confidence intervals, to evaluate our claims. Our analysis indicated that the data did not significantly support our alternative hypotheses, suggesting that the actual rates were close to or above our thresholds. These findings were presented through bar and pie charts to visually display the distribution of murder rates. Our conclusions provide a clearer picture of crime rates in the US during 2013. Our appendices included both raw data and summarized results. The raw data table listed the murder rates for each state, providing a detailed reference for our analysis. We also included numerical summary that captured key statistics like the mean, median, and confidence intervals. Graphical summaries such as bar charts and pie charts illustrated these findings visually. These visuals made it easier to understand trends and verify our hypotheses test conclusions. Together, the appendices served as comprehensive documentation of our data, method, and results. To visualize our findings, we employed several graphical methods. We created a bar graph to display the number of murders per 100,000 people for each state. Additionally, we used a pie chart to show the proportion of states with fewer than one murder per 100,000 people versus those with higher rates. These visualizations helped clarify the distribution patterns within the dataset. The bar graph highlighted variations in murder rates across states, while the pie chart provided an overview of the proportion hypothesis. These graphical summaries were crucial for interpreting and presenting our results effectively. This is our bar graph, and it shows the murder rate per 100,000 people by state. You can see some interesting findings here that Louisiana has the highest murder rate, and while the lowest is Maine. This pie chart shows that the proportion of states with murder rates less than 1 is 0. We also we made confidence intervals, and this is our confidence interval for hypothesis 1. The mean number of murders in the US is less than 5 per 100,000 people. At a 95% confidence level, we get a confidence interval from 3.496 to 4.568. And since the hypothesized mean of 5 lies outside of the confidence interval, we can reject the null hypothesis. Therefore, we have sufficient evidence to conclude that the population mean number of murders in the US is less than 5 per 100,000 people. And here is the math I did for to find the confidence interval. We first find the average and the standard deviation, and then using that, we can find the standard error using that formula. And then the formula for a confidence interval is the average plus or minus t times the standard error. And this second part is also known as the margin of error. This is our second confidence interval. For the hypothesis two, at least 25% of states will have less than one murder per 100,000 people. At a 95% confidence level, we got an interval from 0.122 to 0.358, and 0.25, uh, also 25%, basically 25%, lies within this interval. So therefore, we fail to reject the null hypothesis, and therefore hypothesis two does not have sufficient evidence. We cannot conclude this. The math for this interval is pretty similar. We just take the proportion instead of the average. Next, we do hypothesis testing. On hypothesis one, the mean number of murders in the US is less than 5 per 100,000 people. At 95% confidence level, we get a p-value of 0.0007, which is less than 0.05, and therefore we can reject the null hypothesis, and therefore we can, with sufficient evidence, conclude that the mean number of murders in the US is less than 5 per 100,000 people. The math for this part, you find the t critical value, and then using software, I found the p-value for when t is less than negative 2.58 with 49 degrees of freedom, and that gets you that very low number right there. For our hypothesis testing of the second hypothesis, um, at the 95% confidence level, we get a p-value of 0.00003, which is very, very low, and it is definitely less than 0.05, so we're going to reject the null hypothesis, and therefore we can, with sufficient evidence, conclude that at least 25% of states will have less than one murder per 100,000 people, and mathematically that would be that p is less than or equal to 0.25. And looking back on it, we probably would have been better off choosing a higher number than one here, because in our study, actually 0% of the states had less than one murder per 100,000 people. So we can conclude this hypothesis very obviously and by a lot. And this is the math for that part, very similar. And yeah, in conclusion, from the hypotheses test, both hypotheses were supported, and from the confidence interval, only the first one was supported. And thank you for listening.